The Indian Association of Structural Engineers, also known as IAS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAS-Struct-E is registered under the Societies Registration Act 21 of 1860. IAS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IAS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAS-Struct-E has collaboration with various international professional like-minded associations and institutions. IAS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAS-Struct-E endeavor to ensure that its members develop the necessary skills in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAS-Struct-E's activities are widely appreciated and known for quality technical contents. IAS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IAS-Struct-E's publications are becoming popular with time. IAS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IAS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAS-Struct-E is available on its website www.iastruct-e.co.in.
Vikas, shall I start?
Yes, sir. Yes.
Dear friends, Welcome to this forum where we organize lecture every month. Uh, Today lecture by Engineer A.K. Sharma, and topic is forensic investigation of reinforced concrete structures. Uh, uh, I'll give a little brief about Engineer Anil Kumar Sharma. He graduated in 1976 in civil engineering from Delhi College of Engineering and obtained the first position. And thereafter, he joined CPWD on the basis of engineering service examination held in 1977. He has been a very studious and hardworking officer throughout his career. And during service also, he enhanced his qualification and did his MTech from IIT Delhi in 1987, and thereafter MPhil in Public Administration from Indian Institute of Public Administration. During service, he has various important assignments, and he was engaged in planning, design, and construction of various important projects in different parts of the country. He was responsible for investigating various existing structures in different parts of the country, including South India, and suggested a lot of repair and rehabilitation for more than 65 buildings. He was personally involved in preparing guidelines for repairs and rehabilitation of RCC buildings. He, as I said, worked in CPWD as an outstanding officer, and then he retired from CPWD as special DG 9 years back. And even after retirement, he has been very active in his professional career, and then he's a member of many important uh, uh, forum like Indian Road Congress, Indian Building Congress, and here also we keep inviting him for giving special lectures in IAS also, and every time he has accepted our invitation. So he is member of various committees, BSI and other forum. And, he is also a member of various professional bodies like uh, Indian Concrete Institute, Indian Building Congress, and Institute of Engineers, and many, many more professional institutions. Now, regarding the topic, as I said, the topic is forensic investigation of reinforced concrete structures, where he says that investigation engineer shall create a systematic written record of a deteriorated RC structure, which would help him in not only identifying of the causes of deterioration, but further he will explain remedial action and how to work out further for taking up repairs and rehabilitation work. So now I request Engineer Sharma to proceed and share his experience on this topic. So, Engineer Sharma.
Thank you, Dr. Dhawan, for giving my detailed introduction. And I am thankful to Indian Association of Structural Engineers for inviting me to deliver a talk, and that too on a very important subject, that is the forensic examination of reinforced concrete structures. So let me share with you. Just let me share my screen first with you. Just a minute. So this is the topic, that is forensic investigation of reinforced concrete structures, which I will be deliberating. I think people are able to. Screen is
Yes, sir.
visible.
Yes. Yes, sir. Yes.
So this forensic examination or forensic investigation is as the name suggests, it is a very immersive exercise. One has to deep dive into the concrete technology, and that too through non-invasive instrumentation, without damaging the structure, without existing structure. It is just like an X-ray examination of an X-ray examination or MRI examination of a human body, which is already running, which is already you cannot do the operation to go inside the body, but you have to investigate by looking at the symptoms from outside only. And then you have to find out what the disease is. So this X-ray or MRI or whatever way we may call it, this is a non-invasive investigation that has to be carried out. And this subject being a deep dive subject, this can be subdivided into three categories, three stages. First is the condition survey, which is you can say creation of a written record. Creation of a written record of what we see in the structure, what we visually see in the structure. That written record is created so as to have the complete history from the inception at the stage of the construction through the life of the building and the current condition of the structure. And this condition, what we have now, that has to be cross-verified and confirmed by carrying out the non-destructive tests at locations which have to be identified during the condition survey stage itself. And then based on this written record of visual examination as well as the non-destructive tests, this has to be appropriately tabulated. And based on that tabulation, based on that specialized tabulation, that tabulation has to be specialized so that it should be easy to assess and arrive at the cause of the deterioration and find out the remedial measures. So this is in brief what I will be discussing during my talk. So first of all, let us see what the condition survey first stage is. Condition survey and testing can be utilized. Whatever written record that we have prepared, that can be well utilized for preparation of the detailed estimate of a detailed estimate for carrying out the rehabilitation or restoration of a structure. And also this written record is utilized for prioritization of the areas where we have to carry out the repair first and where we have to carry out the repairs in the last. And then also this written record, which we have created at the time of forensic investigation, this is used for comparison at a later stage for observation and monitoring of the structure after carrying out the repair and rehabilitation at a later date. Even this record is utilized for verifying the repairs that we have carried out, whether those repairs have been carried out successfully or not by carrying out the subsequent non-destructive testing of the repaired structure. Condition survey, as I said, that the creation of the written record, that can be subdivided into 4 stages. Well, first is the preliminary site visit. You see, in civil engineering, without seeing the site, nothing can be initiated. Nothing should be initiated. People can initiate. There are highly innovative people, those who can do the, even without inspection of the site, they can carry out all the jobs. But that is not the right process. Well-meaning civil engineer will definitely make a site visit before taking up any job. So preliminary site visit is a very, very important stage for carrying out the forensic examination of a building structure. And then after carrying out the preliminary site visit, then next stage is the planning stage, where we have to do the planning. And then after planning and after completing the planning and creation of the formats where we have to record, we have to create the written record. All those formats are prepared during the planning stage. And then once planning stage is over, our all formats are ready. Our all preparation for site visit is ready. Then we go for the visual inspection stage. We then have a detailed visit of the site along with our complete team of the professionals, including we carry the non-destructive testing equipments also simultaneously, so that that job testing stage is also carried out simultaneously during the visual inspection stage. Now, what is the preliminary site visit? During preliminary site visit, we get a physical feel of the environment where the structure is located. We get a feel of the nature of distress and what is the extent of the distress and how far it is spread up, which are the areas most affected by the deterioration. And also we take out extensive photographs. Nowadays, for taking the photographs, we also are, you see, my exposure to repair and rehabilitation had been about 25 years back, about a quarter century back. That time, videography was not possible at site. Videography was very difficult. Physical photographs, color photographs were just started, were just initiated. I used to carry the camera with reels, with color photographs. Nowadays, things have been made much easier, that people are having mobile in their hands. They can take the color photograph, they can take the video, even there is a drone facility is available. Earlier, we could not see at the high altitudes, at the top portion of the structures. We could not physically go and see. Nowadays, drones are available. Using the drones, we can create the video of visual inspection, video of the visual inspection. Those days, 25 years back, all these technologies were just not available. So my presentation is based on my exposure to the technology available at that point of time. So this presentation, of course, I will be mentioning about the latest technology in between as and where required. But this exposure, I will be sharing with you based on the old technology. So during this site visit, we have to get a complete feel, and also we have to collect the documents, whatever documents are available, construction record, whatever is available, structural drawings, architectural drawings, whatever is available, year of construction, when the distress was first observed, and how people had dealt with that distress, how they had carried out the repairs, what are the exposure conditions, to what environment the building or RCC structure is exposed to. All those things are felt during the site visit, and documents are collected, and also details of the structural materials used. Particularly, you see, in the last 60 years, lots of technologies have changed in the use of the construction materials. Earlier, we used to have the mild steel reinforcement. This mild steel reinforcement was changed to cold twisted bars. Then these cold twisted bars were replaced with the TMT bars. And all these technology changes also have a great impact on the life of the structure. Similarly, the way we design the RCC elements, those methods, earlier working stress method was there, then ultimate stress method was there, then thereafter limit state methods have come up. Nowadays, we are extensively utilizing the structural analysis using the computers. So all these changes over a period of time of the last 50 years have a definite impact on the life of the buildings, have a definite impact on the rate of deterioration of the building. Even these have an impact. Uh, you see, IS 1893, which is the seismic code, it has undergone a number of revisions. Same is the case with IS 456. It has undergone a number of revisions. All these revisions have caused the have caused the old structures to be reinvestigated from the point of view of upgradation or bringing them in line with the latest standards. So this forensic examination of the building is done from that point of view also. Whatever investigation had been carried out in the past, forensic, it is not that you may be the first person to do the forensic investigation of a building structure. There may be, because building life is enormous, maybe around 75 or 80 years, 90 years, whatever is the building life, during that life, many professionals come and go in charge of the building, looking after maintenance and repairs. So those people might have got the investigations done earlier in the past also. Although all that record of the investigation reports done in the past, that should also be collected. And architectural drawings, maybe you may be able to get, but in my exposure to more than 100 buildings that I had inspected during my span of around 7 years in the field of repair and rehabilitation, I had not come across the availability of the structural drawings of maybe any of the buildings. Maybe one or two buildings. Rather, I could get the structural drawings for Rashtrapati Bhavan. I could get the structural drawings for Parliament House building, which were well preserved. But the buildings which were constructed later on, it was very difficult. Rather, these were just not available. Structural drawings were just not available. So all these documents are very, very important. These should be collected to the extent that you can make them available through the people in charge of the building project which you are investigating. This is the format. This is the format for collection of the data. And this format I had prepared based on my experience. This format necessitates the name of the project with its estimated cost, location of the building, plinth area of the building, year of construction, what was the designed use of the building, what is the current use of the building, what had been the record during the intervening period, whether building was subjected to any change in the building use during the intervening period, structural changes made during the past, made in the past. If those changes were made, what were the details of the changes that were carried out? When was the first discharge? You see, it is very important to note the date of completion of the building and the date of the period between the date of completion and the date of first distress notice. Normally, RCC buildings are designed for a design life of around 75 years as per the available literature. So 75 years should be the normal lifespan of RCC buildings. But there are instances where the distresses have been noticed even after 4 to 5 years, 10 years, 20 years, 40 years, 50 years, like that. So this period of the year of completion and year when the first distress was noticed, this gives you a lot of information about the quality of construction and the nature of distress that you had come across. Then nature of distress notice, any previous investigation done in the past, then we have to get hold of the investigation report from the owners of the building. Any repairs which had been carried out in the past, then details of the repairs which were carried out with the year of carrying out the repairs, types of repairs, efficacy, their effectiveness, whether those repairs were effective or those were not effective. All these have to be understood from the record. Then what was the cost of the repairs which were carried out? All these investigation reports copies we should collect. Then in the construction, what type of cement, whether OPC, ordinary Portland cement, which used to be used in the construction till 2010. As in CPWD, I'm talking of the CPWD. OPC was used for RCC construction till 2010. From 2010 and onwards, PPC had been allowed to be used in the construction, and sulfate resisting cement was also used, is also used in case of the marine structures where sulfates are excessive. PPC had been used in CPWD in the year 1965 to 1989 or so. The 65 to 89, this is the period when PPC was used, and that PPC was proved to be of inferior quality, and this any construction carried out in CPWD or in government construction during this period using this PPC, which was made from the surki. That is surki means that is from the ground bricks. Ground bricks, surki is a pozzolanic material similar to fly ash. The way fly ash is a pozzolanic material that is being added in PPC nowadays. Earlier, surki was being added to the OPC to make the PPC, and that quality of surki which used to go into the PPC, that was questionable. That was untested. Untested surki was being added to the cement during the period of 1965 to 1989. So that construction during the 65 to 89 using this PPC is also a question mark. So all these details give you a lot of insight information about the quality, about the structure while you are carrying out the forensic investigation of a building project. Similarly, the reinforcement. Mild steel, as I mentioned just before, mild steel way back about 40, 50 years back, cold twisted steel bars, TMT bars, or any other kind of steel like galvanized steel or stainless steel. These have also been used in the construction of importance. So, for example, mild steel used to be relatively less corrosive. Cold twisted steel bars are more corrosive because these used to have the higher carbon content. And nowadays, the TMT bars are relatively less corrosive due to lesser carbon content. And source of water. What was the source of water used for original construction? So whether it was a municipal water, local bore well water, and any other source. If it was a local bore well water, then we should, whatever water was used, we should again test the sample and get the water test report about its suitability for the construction. And chemical analysis of the results of the water will give you quite good insight into the cause of the deterioration of the building. Then source of sand and its chemical analysis, whether sea sand was used or fresh water or fresh river water sand was used, all these things. And source of coarse aggregate, including the type of rock, photographs of the defective portions, if any, they are having, set of architectural drawings, set of structural drawings, details of any protective treatment used during construction. Protective treatment like cladding, many times surface cladding used for protection from our architectural point of view. So all these things are important from the point of view of knowledge for the forensic investigator carrying out the investigation of the building. immediately after the carrying out the site inspection, after carrying out the site visit, we are duty bound. We as a forensic investigator is a duty bound to issue the written instructions based on the site inspection. And in that written site note, we have to clearly give the written directions for any remedial measures to be taken for the safety of the structure, for the safety of the people, life safety of the people already using the building. And this has to be a part of the site inspection note. If there are any restrictions in the sites while carrying, if there are any restrictions which you could not, which you feel that those can be removed during the actual site investigation, though that should also be written there, that these necessary site preparations should be made for inspection of the portion of the building where there are restrictions in the visual inspection or carrying out the testing at the site. Then needed site preparation with safety requirements are also necessary, because while you will be going for the detailed inspection for recording of the visual examination, etc., that time you will be requiring the scaffolding for accessing the site with your test equipment. So needed site preparations with safety requirements have also to be a part of the inspection note. Based on this preliminary site visit, we have to identify and list out the needed field equipments for non-destructive tests or for taking out the samples of the concrete or reinforcement from the site. And also this preliminary site visit will be helpful in identifying the quantum of survey work involved and size of the inspection team that you have to take along with you, and how much time will be needed. For example, for inspection, you may require a week, maybe you require 2 weeks, maybe you require 2 days, depending upon the site of the structure. So all these things are to be facilitated based on your preliminary site visit. And once we have completed the site visit and we have collected the site data, then we have to study all whatever we have collected from the site, including the previous investigation reports, maintenance and repair records. All these we have to study and we have to understand what all had gone into the past. And based on that, we have to identify, we have to define our objective, with what objective we have to go in for the detailed site visit. So we should clearly, our team should very clear, our team, survey team should be very clear in its objective, survey objective, with what objective we are going to the site. What should be the scope of the work? Maybe that there are 3-4 buildings that we have inspected, but our scope, we are limiting to only a portion of the building, and beyond that we are not to inspect. So all these things should be known to the, not only the survey team, but also it should be made known to the owner of the building that our objective and our scope of work will be limited to that, so that we are able to concentrate on that area. Then survey methodology, type of field test, laboratory samples to be taken from the site, and then sequencing of the task with identified responsibility. You see, we are carrying the survey team. Every member of the survey team, every member of the investigation team should know what are their duties during the site visit. All those duties should be identified and made known to the every individual, and he should be equipped with the appropriate equipment, so that immediately the moment we reach at the site, we should be able to start the job without loss of time. You see, distresses are varied, and all the distresses do not require the same type of treatment. Some distresses may require only symptomatic, redecoration. Some distresses may be superficial, having no impact on the structural strength and life, and some may be requiring only superficial or general repair, or, and some may be requiring structural repair, and some may be requiring the major repair involving the retrofitting or something of that sort. So these repair requirements are classified normally into these 5 classes: class 0, class 1, class 2, class 3, and class 4. And this is how these can be classified. You see, God has given you the eyes. God has given you the eyesight. Visual examination of any structure is the most effective qualitative method. So, keeping this in focus, we have to do the planning. You see, an experienced engineer, simply by inspecting the surface of the deteriorated concrete, can most of the time come straight away to the conclusion that this could be the cause of the deterioration. So visual examination is the most effective qualitative method of forensic examination. This is what I am saying. People talk of the NDT, etc., etc. I have seen many people, there are illiterate, I can say illiterate people doing the forensic examination and issuing the investigation reports. And I find I have come across with a number of people after my retirement who have issued the report. Those reports are deficient. They are only based on the Smith-Hammer test, UPV, or maybe core cutting, and without any reference to the visual examination, without any record of the visual examination. So such type of useless professionals, so-called professionals, they are rather they are defaming the professional practice of the repair and rehabilitation, or those who are doing it really investigative job. So visual examination and the record of visual examination is a very, very important record that should form the basis of the forensic examination of any building structure. So for this purpose, we have to do the planning. We have to create the record for recording the visual examination at the site. And then using this record of the visual examination that we have actually recorded, that should be helpful for finding out the cause and extent of the distress and extent of the repairs to be carried out, even preparation of the detailed estimate thereafter. So the drawings, if as-built drawings are not available, we have to prepare the architectural drawings with the structural elements incorporated there in between. Architectural drawings, I do not mean all architectural features, all structural architectural plans with only structural features. Or you can say the structural framing plans we should prepare based on the available architectural drawings or based on the field measurements. So, and then using those framing plans for each floor. Framing plans have to be available for each floor. And also, if it is a large building, then different portions of the building, each section of the building, we should have floor plans. Also, we should have the grouping of the structural members based on the exposure condition. Grouping does not mean that, for example, this is the framing plan of a building. For example, this is the column C1. This C1 column is similar in exposure conditions as this C1 column. So we should do the numbering of the structural elements based on their exposure conditions. For example, this C5, C9, C13, C13, C9, these columns are all exposed in one direction. These are exposed to external environment in one direction. I'm talking about the normal building. So these columns can be grouped into another category. Similarly, this toilet area or kitchen area, which are the wet areas. These wet areas, here the RCC beams and columns, these are likely to be subjected to alternate wetting and drying. So these will have a different scenario altogether as far as the exposure conditions are concerned, as far as the distress nature of distress is concerned. So these should be grouped separately. So like this, we have to do the grouping of the structural elements during the preparation of the drawings, spreadsheets and tables. And this grouping of the structural elements have to be again separated. For slabs, there should be a separate grouping. For beams, there should be a separate table. And for columns, there has to be a separate table. And these have to be placed on the, these have to be linked with the spreadsheets. And the spreadsheets, what the spreadsheets are, these should essentially contain the plan of the building at each floor with each structural element drawn to a convenient scale with all the relevant information, dimensions, openings, and any unusual features reflected so as to enable the survey. So as to enable the survey, so as to enable the investigator record his visual observation on the floor plan itself in a suitable notation with the type of the defect, what type of defect was there, with its location on the plan itself, what was the quality and extent of damage. All these have to be recorded on the floor plans, that is called the spreadsheet, duly connected with the tabular form. These have to be tailor-made for the structural element, that is slabs, beams, columns of the project under investigation. This is how floor plan is there, framing plan is there, and on which, for example, slabs, we have marked that this is the portion of the slab. This is the area which has got the reinforcement exposed. Cover concrete is delaminated and exposed reinforcement is visible. For example, this beam here, this is the beam having cracks. Like this, we have to mark on the floor plan to the extent we can in a suitable scale. Also, this should be correlated with the tables having slabs, beams, and columns. And in those tables with slabs, beams, and columns, we have to appropriately mention the dimensions also, area or length of the cracks, etc. Also, so that we should be able to measure the length of the crack, area of the portion, and prepare the appropriate detailed estimate. For example, these are the notations that we can mark. In case of the slab, the area, approximate area having loose cover concrete. This is the area which is having a spalled cover concrete. This is the area having the spalled cover concrete with the reinforcement also exposed. This is the RCC slab having cracks to a suitable scale with the length of the crack, and then grazing cracks, etc. All these we can have the notation, and using that notation throughout, using the same notation, we have to mark on the floor plan. Similarly, in case of the beams, for example, so this is the area where the cracks are there. So this is the here you see this notations have been given in the handbook on repair and rehabilitation. If you see that all these notations are given, how to mark it, so that at a later date you can prepare the estimate of the length of, find out the length of the crack, height of the column which is damaged, area of the slab, area of the column which is having delaminated cover concrete, etc. All that detailed estimate can be prepared using these tables and notations which can be used. For example, A, B, C, B, these C, B or A, B, etc. These are having specific meaning. Distance from the left face of the column. So for example, to locate this, the distance from the face of the column is A, distance, location of the uh, this this length of the loose cover concrete is B, and C minus B. Like this is a table given in the handbook on repair and rehabilitation. Using that handbook table, you can clearly mark on the table or spreadsheet the what you see, you are able to mark. Not only in respect of the slab, but also in respect of the beams and also in respect of the columns also. This is for the columns. That table is given there in the handbook on repair and rehabilitation. So as I already mentioned, visual examination is the most effective qualitative method. It forms the basis for working out the testing program. It is useful for finding out the causes and extent of the distress, and it should be duly supported. It should be duly supported with a good photographic record during such inspection, which is very, very important. Nowadays, you can even prepare the video recording also, but that is more. I find still photographs to be better than the videography. This visual examination, it assesses the general state of the health of the structure. Information, it gives you information regarding the workmanship, structural serviceability, and material deterioration. Instruments for measuring crack width, etc., are the simple tools and other simple tools like camera, rebound hammer, etc., are usually needed for carrying out the visual survey. While carrying out the visual survey, you may come across with a large number of impediments like false ceiling, carpets, false flooring, etc., because of which you are not able to see the structure, actual structure. So whatever you have not been able to actually see visually, that should be recorded, that these were the visual impediments, and these should be recorded on the spreadsheet itself. We have to identify during visual inspection the areas having high distress from the safety point of view, distress area in different exposure environments, identifying distress due to structural overload, cracks, map of the crack that gives you enough information whether those structural overload has caused the flexural deterioration or shear failure or torsional failure or columns are overloaded due to axial load, whether the distress is on account of not because of the loading, but because of the corrosion and reinforcement. All these you are able to identify, and you should accordingly, you should have from the record, you should be able to identify all these type of nature of the distresses. Wherever excessive deflection, you notice vibration in the structure, that also gives you a lot of information. All these should be recorded on the spreadsheets. Moisture, leakage, seepage, and dampness, algae, fungus growth, efflorescence, etc. All these give you enough information about the leakages and seepages going into the structure. And these should be appropriately recorded through the photographs. And these are the notations that you can use it. These are also given there in the handbook on repair and rehabilitation. And these are the cracks, which could be on account of excessive sulfate in the concrete, in the cement paste that we have used, or these cracks could be on account of the alkali aggregate reaction also. So non-destructive tests are mostly on account of using the non-destructive test. Just a minute. Using non-destructive tests, we have to determine the quality of reinforced concrete, means the quality of concrete that has gone into the structure, and also the extent of corrosion in reinforcement, or the quality of reinforcement and the extent of corrosion, ongoing corrosion in the reinforcement. These are the two different areas of the non-destructive testing that has to be carried out. And for as I mentioned, that these tests, visual examination is the base. That base has to be certified or has to be validated using the non-destructive test. And you see, in original construction, we carry out the test of the concrete, test of the reinforcement at the initial stages, and we are doing it periodically. They are at a certain frequency. But that is not the case in an existing building. In an existing building, most of the information you gather it from the visual examination, and that whatever visual examination you have gathered the information, that has to be validated using the non-destructive tests. Non-destructive tests are only to confirm whatever you see, that is confirmed. And that confirmatory testing entity gives you a confidence, and it gives you some number. Using that number, you can qualitatively or quantitatively, you can differentiate the level of distress. That number is given through the non-destructive test. For testing the quality of concrete or strength of the concrete, Smith hammer is the most used instrument during the field investigation. Next is the ultrasonic pulse velocity test that is used in the for testing the quality of the concrete. Windsor probe, cut and pull out test, core cutting and testing, and load testing, impact echo test. All these tests are used for assessment of the quality of the concrete. And we will be dealing with these tests in the subsequent part of the presentation. The different test methods have a different connotation as far as the speed, as far as the cost, and the extent of damage that is caused to the structure. For example, load test. These are the different tests what I mentioned to you. Smith hammer, ultrasonic pulse velocity, Windsor probe, and these tests, for example, load testing of a structure is highly costly. Speed is very slow. Damage caused is variable. It can cause a major damage. It can cause a no damage. Representativeness is again variable. Reliability is good. Smith hammer test, cost is very low, fast, no damage is caused to the structure. Representative, it represents only the surface hardness, and reliability is not that good. It is termed as poor. Ultrasonic pulse velocity test, that gives you the uniformity and the denseness of the concrete. The cost, UPV test cost is again low, speed is fast, damage caused is none, and representativeness is good, and reliability is moderate. These are all qualitative tests. These do not give you the actual strength. Even though people are giving the strength based on the Smith hammer, but that Smith hammer strength is also a qualitative, and you cannot predict the strength of the concrete in an old existing structure using the Smith hammer test. Only you can qualitatively say using the Smith hammer that yes, strength is excellent, strength is good, or strength is poor. So Smith hammer, I have seen the investigation reports by the third parties who arrive at the strength of the concrete using the Smith hammer test in an old structure. That is incorrect. New structure, if you are constructing a new structure, you are casting new concrete, you can arrive at by calibrating the chart, by calibrating the Smith-Hammer chart and using the same material which is going into the new construction. You can calibrate it and you can find out relatively, reasonably acceptable strength of the concrete using the Smith-Hammer, but not in case of the old structures. Then Winthrop probe, it is a fast. I have not used the Winthrop probe or Capo pull-out test, but these are, I will be dealing with this. And Winthrop probe, it's a moderate cost. It is fast. It is used using the just like pistol, using gunpowder, and it is moderate. Speed is very fast. Damage caused is minimal, and it is also representing only the surface quality of the concrete. Capo and pull-out test, it is a moderate cost. It is also fast. Damage caused is minor. It is also giving quality of the concrete, all near surface. You can say cover concrete maximum, and reliability is moderate. Then core cutting. Here core cutting, I am not able to, I think you may be able to see the core cutting. Core cutting, core testing. Here cost is moderate, is relatively costlier, slightly costlier. Speed is slow. Damage caused is moderate because concrete is taken out from the structure. And reliability is good. It gives you the in situ strength of the concrete by testing the concrete core in the laboratory. This is the Smith-Hammer. Now I will be dealing with the Smith-Hammer test. This is the Smith-Hammer test being carried out on the RCC column. You see, you may be seeing this part of the concrete has been cleaned. It has been planed. And after carrying out this preparation of the surface, then only the Smith-Hammer test can be carried out, so that it should not hit the aggregate. It should not hit the only mortar. It should give the surface quality, surface hardness of the, because in concrete, old concrete, surface gets carbonated. Surface is chemically reacted with carbon dioxide, and calcium carbonate is formed on the surface, directly on the surface of the concrete. So that hardened surface has to be removed using the emery stone, and that should be rubbed plain. And as far as the immediate top surface should be removed, and any protruding aggregates, etc., should be avoided for doing the testing using the Smith-Hammer. Smith-Hammer test is a hardness tester. This is the Smith-Hammer. This is the cross section being drawn. This is the plunger, and this is the weight which hits the plunger, and it falls on the plunger. So it is being applied. This plunger is loaded, and this weight is made to this weight is made to freely fall from a fixed height every time, so that fixed energy is imparted, and this rebound value, this weight is rebound back. That rebound of the weight is noted as a rebound value. And using these charts, even though these charts are giving the strength of the concrete, but using these charts, depending upon the angle of inclination of the rebound hammer, if we are using it for the slab from below, then the rebound value will be different. Same Hammersmith hammer, if we are doing it from top to the in the reverse direction at 180 degrees, then the rebound value will be different. So these rebound values are corrected using the angle of inclination of the rebound hammer from the surface of the concrete. For example, plus 90 degrees, plus 45 degrees, 0 degrees, and then minus 45 degrees and minus 90 degrees. So if we are using it horizontally, rebound hammer we are using on columns horizontally, then the rebound value for the same hardness of the concrete will be different. So this is how these rebound values can be interpreted using these charts. Smith-Hammer test, it measures the relative hardness at or near the surface of the concrete. It measures the hardness in terms of the rebound number. Rebound number is how much that reading comes as the rebound value of the hammer. It's just like जैसे लोहे का जैसे शीशे का कंचा हम कंचे से खेलते थे बचपन में, सभी बच्चे खेलते, आजकल तो बच्चे नहीं खेलते, पर पहले बच्चे कांच के कंचे से खेलते थे. Harder is the surface, higher is the rebound of the कांच का कंचा, lower is the hardness of the, lesser is the hardness of the surface, the kancha will not rebound back. So this is how the rebound number is, and appropriate code is IS 13311 Part 2 1992. Maybe now it has been revised. I think it is not in 1992. Now the revised code has come probably, to my understanding. Smith-Hammer test is affected by the type of cement. What type of cement has been used in the concrete? Coarse aggregate, what type of coarse aggregates? Moisture content in concrete, surface texture of concrete. If it is a rough texture or it is a smooth texture, so that is why the smoothing of the concrete surface is necessary before we carry out the rebound hammer test. Carbonation, to the older is the concrete, higher will be the rebound value. Newer is the concrete, lower will be the rebound value, because surface of the concrete gets carbonated, and that hardened surface, carbonated surface, gives you higher rebound value. Curing conditions, then direction of the rebound hammer, all these things are important. Smith-Hammer is used for strength assessment of the concrete. It is used for survey of the weak and delaminated concrete. It is used for assessment of the relative strength of the structural members within the same structure. Here, in case of the forensic examination, Smith-Hammer is used basically for this purpose, to find out the relative difference in the quality of concrete at different locations within the same structure. Here, Smith-Hammer is not used for strength assessment. Here, Smith-Hammer is not used for survey of the, for getting the strength of the concrete. Only it is used for relative examination of the concrete. Relative quality of the concrete, whether this concrete is better than that concrete, or that concrete is better than this concrete, like that. So Smith-Hammer test is used only for very rough qualitative assessment. These are the standard as given in the code. Higher than 40, if you get the rebound hammer reading more than 40, it is considered very good concrete, very good quality of concrete. 30 to 40 gives you an indication that it is a good concrete. 20 to 30 fair, less than 20 poor or delaminated, or less than 10 is very poor or delaminated concrete. Next is the ultrasonic pulse velocity test. It measures the travel time. Within it measures the travel time T of the ultrasonic pulse from transmitter to receiver over a length, measured length L. The length, for example, we are having a 300 mm column. So on the two faces of the column, one side we are putting transmitter, the other side we are putting a receiver, and 300 mm length is known. So time of travel of the ultrasonic pulse from one face to the other is measured, and velocity is determined in terms of the kilometer per second. And that kilometer per second is related with the quality of the concrete. For example, if the ultrasonic pulse velocity is more than 4 km per second, quality is considered very good or excellent. 3.5 to 4 km per second, good to very good. And 3 to 3.5 km per second satisfactory, and less than 3 km per second is poor. So ultrasonic pulse velocity test is used for assessment of qualitative homogeneity and integrity of the concrete. It is used for gradation of strength in different parts of the structure. For example, beams, different beams, we can directly differentiate the quality of the concrete between the in columns or beams at different locations by carrying out the ultrasonic pulse velocity test, UPV test. Locating discontinuity in the cross section. If the there is a crack in between, so ultrasonic pulse velocity will not be able to travel directly. So it will give you understanding of the discontinuity in the cross section of a RCC element. Depth of crack below surface can be determined using the UPV method using normal trigonometric formula. The factors affecting the reading of the ultrasonic pulse velocity test are the water cement ratio, aggregate type, surface condition of the concrete, moisture content of the concrete, age of the concrete, temperature, micro cracks, presence of steel reinforcement in the concrete. You see, steel reinforcement is present. We should not carry out the test through the reinforcement because steel reinforcement will give you erratic. Presence of steel reinforcement will give you erratic readings in the UPV value. Then cut and pull out test, capo test. Here it measures. This is the instrument set. This is the cut and pull out test. You see, this is the cavity. We drill a hole and then we put a cavity here. A disc is inserted later on, and using this method, we apply a force. We apply a force. It measures. We apply a force, and that force is measured to pull the steel disc or ring embedded in the concrete against the circular counter pressure. This is that circular counter pressure. You see, this is the pipe, and we are pulling it out using. We are applying a force here. This force is determined to make this disc come out, and this through this cone. This cone will be pulled out. This ultimately, using this cut and pull out, this cone will be pulled out, and for pulling out this cone, we determine the force. And this force is a direct measure. That is a direct measure of the strength of the concrete. So pull-out test, the principle is, it measures the force required to pull a steel disc or ring embedded in concrete against a counter pressure placed on the concrete surface concentric with the disc oblique ring. Results are found to be in close relation, very close, and within 8% of the accuracy of the actual strength of the concrete. The surface at the test location is the ground using a planing tool and a 18.4 mm hole. This is what we have detailed out the complete procedure and instrumentation. This is how the force is being applied. That disc is inserted and the force is being applied using this instrument. And when that cone is pulled out, and that maximum force is recorded on this instrument. And that force, so it is, the applications are for quality assurance, for testing of the finished structure, verification of in-place strength, if the strength of the standard cured specimen fails to meet the acceptance criteria. For example, wherever cube strength, etc. fail in the original construction I'm talking. Estimating strength of the concrete in existing structure. And then the factors which affect the capo test are the aggregate size. The recommended aggregate size for concrete with aggregate is up to 38 mm. If the size of the aggregate is more than 38 mm, then capo test is not recommended. This is a Windsor probe and PNR tester. These are the tests using the, just like a, you can say, gun type. It measures the penetration depth of a standard smokeless gunpowder, actuated hardened alloy. Here, a pin is fired using the standard smokeless gunpowder. And I have not practically used it, but this is the test I am telling you. These are available, and I have practically not used it, but these are available and these are being used by the people those who want to go in the depth. Penetration is not affected by the advantages. The advantages, the factors which affect the reading are the strength of the mortar, type of the stone aggregate, aggregate hardness, verticality of the board relative to the concrete surface. If we are not applying it at right angles, then that will be affected. Then PNR tester. Here, both these tests are used, Windsor probe and PNR tester. These are used for determining the relative difference between the strength of the different concretes. And these can be calibrated in case of the new construction, but not in case of the old construction. And this is the core cutting and testing. This is how the core is being cut. This core is taken out. This is the normal drill machine type of thing. This is and here diamond core bit. Diamond core bit is used here, and using this drilling machine, that core cutting is taking place, and these are this is how it has been using this strong connectors, and it is core is being taken out. This is practically being done by our people. This is how it looks like after taking out the core. These are the telltales of the fixing arrangement of the core cutting equipment. Core cutting and testing. It measures in situ actual compressive strength density in the laboratory. We carry out the compressive test in the laboratory, and we arrive at the actual compressive strength of the core. We also are able to determine the actual density of the concrete. We are also able to determine the depth of carbonation of the concrete by spraying the phenolphthalein indicator. Just a minute. For example, this is the freshly cut core, concrete core, and the portion of this is the portion depth of the non-pink area. Depth of the non-pink area of the core. Whatever is pink, that is a good concrete. Whatever is non-pink, wherever color has not changed to pink, that is the carbonated depth of the concrete. So we are able to measure the strength of the concrete. We are able to see the texture of the concrete. We are able to visually see the texture of the concrete, and using the petrographic, we can do the petrographic analysis by actual microscopic examination of the surface of the concrete. Then also we can determine the water and gas permeability by taking out the slices of concrete from the core. And using the powder of the concrete core, we can also do the chemical analysis of the concrete actually which has gone into the construction. Factors which affect the compressive strength of the concrete is H/D ratio. You see, every time you take out the core, it may not be actually cylindrical. It may not be actually in the shape that you desire it. The ideal ratio of H/D should be equal to 2. Height should be double the diameter of the core. But actually, you may not get it. Actually, the core will be damaged while taking out the core. So, top surface or bottom surface may be damaged. We may not be able to extract the complete core. So, the core has to be repaired using the molten sulfur. It has to be brought to the exactly cylindrical shape, and whatever is the H by D ratio, appropriate correction has to be applied, and that it will give you the cylinder strength, and that cylinder strength has to be converted into the tube strength by applying a appropriate formula. Here, the limitation is we have to take the core only in the area where steel reinforcement is not available, is not embedded. So before deciding the location of the core, using the rebar locator, we have to identify where reinforcement is. It is a reinforcement free area. Small dia cores are exhibiting more variability than the large dia cores. Normally, it is the 3 times the diameter, 3 times the nominal size of the aggregate. That should be the core diameter. It should be larger than 3 times. For example, 20 mm aggregate size, we should have 20 into 3, that is equal to 60. So 60 normal core bits are available, 50 mm, 75 mm, 100 mm, or 150 mm. So next is the 70. So normally, in case of normal concrete, 75 mm dia core bits are used for taking out the core. This is the practical factors affecting the pressure strength of the concrete, age of the concrete. You know about it. Strength of the concrete matters as far as the drilling operations. The drilling operation has to be carried out by an experienced person who should be able to hold that. There should be drilling operation is very important, and it has to be done by an expert. It has to be done at right angle, and it should not be vibrating. That person should not be vibrating. Site conditions have to be appropriately looked into as far as the reinforcement, presence of reinforcement or surface preparation, etc. is concerned. Then another method is impact eco test. You see, during that stage, 25 years back, this method was developed. It had just developed. It looks for the flaws and imperfections in the material. It can estimate the thickness of the concrete to the accuracy of about 3%. It is primarily used for concrete and masonry. And it is developed using the same ultrasonic pulse velocity, ultrasonic pulse, but here pulse is reflected back. So it is the echo of the pulse which is mapped. Here that impact is given. Impact is given using this is the mass. Using this is spring loaded. This impact is given, and then surface fluctuation of the surface is also measured. So transmitter, it gives you the pulse. This is the transmitter. It gives the pulse echo, and it is this transmitter is spring loaded, and it's a large impact. This transducer also measures the surface displacement. This is the surface displacement is being measured at this location, and this is done together. Plain reinforcement and post-tension concrete, it is used. It can be used for sensing the cracks in the structure, delamination, voids, honeycombing, debonding, and it gives you a picture using the computer software. It gives you the reflected image of the the defect in the structure. So say for example, this is the void. So this is the impact. Impact is given here, transmitter and transducer received it back. So it gives you the location of the defect, and also it gives you the thickness of the member. So impact produces the stress waves in the material. Reflected waves from the voids are detected by the transducer. These reflected waves set up a resonance condition having a distinctive frequency. Waveform is transformed into the spectra and should have an idea of what to look for. The size of the flaw is it's given, and it operate parallel to regular occurring grooves. The advantage of this is that it needs only one surface. We do not require both the surfaces. For example, in UPV, we require the two surfaces of the concrete. Here, it can be done only from the one surface using the echo of the wave. Internal flaws can be detected. It can determine the depth of the internal flaws. It is easily repeatable. It can construct a map of discontinuities and deficiencies are. The disadvantages are the data can be difficult to interpret, especially on thick plates or on layered materials with overlays. For example, if soil is there, or if there are 2-3 layers, then it will be difficult to interpret the results. Small voids can be missed. Complicated geometries pose difficulties. Flaws beneath the sensed flaw must be evaluated. If there is a flaw below the flaw that cannot be sensed by this, we have to do it from the other side of the other side of the cross section of the concrete element. Flaw detection length cannot be determined so easily. That is there is a restraint, that is 1/10 of the thickness of the element. This is the basic equipment. I have not practically used it, so that is why I am not very fluent in speaking about this. But this is available in the market. It is available. The people, those who are doing it, non-destructive testing. Then now is the chemical. You see, reinforcement corrosion is directly impacted by the chemical quality of the concrete. Reinforcement corrosion starts when the level of alkalinity of the cement paste goes down. So directly measuring the pH value of the cement paste in contact with the reinforcement gives you the likelihood of the corrosion susceptibility of the reinforcement. So chemical attack assessment can be done, can be assessed using the field methods by using the phenolphthalein test, using carbonation depth, and using the chloride test by taking the samples from different depths of the concrete. And the samples taken from different depths of the concrete from surface, those samples can be tested in the laboratory for chloride and sulfate tests, pH of the concrete at various depths that can be determined, and proportions of cement and aggregate can also be worked out using the powder taken out from the while drilling from the surface of the concrete. Corrosion potential, because thickness of the cover concrete is very important from the point of view of the corrosion. So cover meter surveys are carried out using cover meter. Half cell potential. These are the corrosion chances of corrosion of the structure. For that, thickness of the cover is important, and then half cell potential survey. You see, corrosion is a electrogalvanic process wherein a corroding reinforcement, corroding anode corrodes, and there is a potential difference between the anode and cathode. So half cell potential survey gives you the voltage difference between the reinforcement and the concrete surface. Then resistivity of the concrete. Resistivity of the concrete is also very, very important. You see, higher is the resistance in the concrete, means that concrete will be less susceptible to corrosion. And then evaluation of corrosion rate, that will give you the likelihood of the corrosion rate will give you the lifespan of the remaining lifespan of the building. So this is how that phenolphthalein spray means pink, if we are getting the pink concrete means this concrete is good in quality, and it will not, it is this concrete or cement paste in this concrete is healthy. This concrete is healthy and it will not allow the concrete to corrode. So field methods of determination of the pH are the Clostridium test and laboratory tests for chloride and sulfate. So cover meter survey is done. This is the cover meter. This is the cover meter. It gives you the thickness of the cover concrete above the reinforcement. Also, it gives you the diameter. Also, it gives you the diameter of the reinforcement. Also, it gives you the location of the reinforcement. So this cover meter survey is carried out. Here, reinforcement is also located. We are using this instrument. We are able to get 3 items. One is the thickness of the cover. The other one is diameter of the reinforcement. The third one is the
Location.
uh,
Location of what?
one is we are
Location of
getting
what?
location of bar. We are getting location of bar, dia of the bar, and also the thickness of the cover concrete. So using this equipment, we are able to find out the cross section of the presence of the steel reinforcement with its percentage also we can find out. This is the half cell potential meter. It is a copper. Here, copper anode is there, copper sulfate solution is there, and it is connected with the reinforcement surface. It is connected with the reinforcements. This is a wetted. It is connected with the RCC concrete surface. This concrete surface is wetted, and this this is the cork connection, and it is connected with this, and it is connected through this wire. It is going and it's connected with the reinforcement and surface of the concrete. This is how a cell is formed, half cell is formed, and reinforcement, and the potential difference between these two, reinforcement and surface of the concrete, is measured using this instrument. And this half cell potential reading gives you enough insight about the probability of the ongoing corrosion in the reinforcement in the structure. So it gives you probability in the range of 0 to 10%, or up to 50%, or 90 to 100% corrosion ongoing. So these are the 3 stages. Again, it is a qualitative test, but using this method, we can plot the contour plan of the area which is more susceptible to the likely corrosion. And after carrying out these NDTs, visual examination, and all these things, these are tabulated in this format. This is the format for concrete strength assessment, and the other format is for the corrosion assessment of the steel reinforcement. These 2 formats here, you see, no single, it has to be remembered that no single method of non-destructive testing gives you a confidence of the strength of the concrete or the likely potential in the concrete, or a likely corrosion potential of the reinforcement. So it has to be all that, no single test can be relied upon. For example, if we have to assess the strength of the concrete, it has to be assessed not only through the visual examination, but also it has to be verified by using different methods like Smith-Hammer test, UPV, and core test, and petrographic examination. All these have to be listed, and simultaneously these have to be appropriately interpreted by an experienced engineer. Here, for example, for the group of exposure here group of exposure, as I mentioned to you, that we have to do the grouping of the structural members, columns, beams, etc. All these have to be grouped depending upon the exposure condition. That group of exposure have to be listed all in one place, single group in one sheet, and all all structural members have to be listed out, and then spreadsheet reference number, whatever spreadsheet we had noted down from those spreadsheets, the data has to be transferred on this table. And on this table, then what had been the velocity in kilometer per second as far as the UPV test is concerned. Then whatever the qualitative grading. Then Smith-Hammer. What was the rebound number? What was the rebound index? And what is the qualitative grading? Here you see, I am not mentioning anywhere about the strength. We are only saying about the qualitative grading. Then crushing strength. Core test gives you the crushing strength. Here you can mention about the crushing strength of the concrete as you assess from the crushing strength test of the core. And then density of the concrete. Density of the concrete also gives you a lot of information about the concrete quality. Higher is the density, higher is the better is the quality of the concrete. So concrete core density, and what is the percentage of the density with reference to the reference standard density of the concrete. That percentage, and then quality grading. Then visual observation of the petrographic examination. Based on the petrographic examination, what was the visual observation? So this table is the sum and substance. This table is the sum and substance for determining the quality of concrete in different groups of exposure of the structure and different members. Each member also we can find out using this method, this table. These have to be tabulated. No single entity will give you the confidence of the quality of the concrete or quality of the corrosion potential in the reinforcement. Now we come to the reinforcement. Reinforcement for corrosion assessment of the reinforcement, thickness of the cover concrete is important, depth of carbonation is important, half cell potential is important, and pH of the cover concrete is important. Chemical test results of cover concrete means what was the chloride content and sulfate content, and then reduction of bar diameter. If the bar diameter goes down substantially during the actual field testing, that also gives you enough insight and necessity of putting additional reinforcement during the repairs and rehabilitation. So here the columns what we have mentioned is again from the spreadsheets we are transferring data onto this final sheet, group of the exposure, member number, spreadsheet number, and then thickness of the cover concrete in that group, specified thickness and actual thickness, actual cover thickness, depth of carbonation actually measured, whether the reinforcement needs to be exposed all around or not. If the depth of carbonation has gone to the reinforcement level, in that case, it has to be, while carrying out the repair, the concrete has to be cleaned all around the reinforcement so that the fresh concrete is replaced. Old concrete is replaced by the fresh concrete to restore the protection of the reinforcement. And half cell potential reading, A, B, and C. A 0 to minus 200 millivolt, minus 200 to minus 350 millivolt. Here it is 50% probability. Here it is 10% probability, and here it is 90% probability of corrosion. A is 10% probability of corrosion. B is 50% probability of corrosion. C is 90% probability of corrosion. So whether based on the half cell potential reading, whether it falls in A, B, or C, all these have to be written here. And then pH of the cover concrete. what is the pH of the measured value of the cover concrete in the laboratory of the sample that we had taken from the site. And chemical test results of the concrete that we had taken to the laboratory, or the concrete core that we had taken. So those samples were tested in the laboratory, and what was the total chloride content and sulfate content in the concrete samples. And reduction of bar diameter. For example, in case the bar diameter gets reduced to the extent that only around less than 85% of the area of reinforcement is remaining. Say 20 mm diameter bar gets reduced to, say, 12 cross-sectional area is reduced to equivalent to less than 85%, then we have to put additional reinforcement during the repair and rehabilitation. So like this is how it so what in the sum and substance, what we can say that forensic examination is a detailed examination. It has to be carried out by experienced engineers who understand the concrete, who understands the and it cannot be based on the single entity. Single entity will not give you the idea about this, and it has to be this tabulated, and this table has to be appropriately assessed by an experienced engineer with his reasons. Here, the general observation, including prioritization based on distress, deterioration, or deterioration noted. So whatever you use all these information to arrive at this conclusion, and finally arrive at the recommendation and reasons for, and justifying reasons for the recommendation. So this table is the sum and substance of the entire exercise, and this is how we should arrive at the final decision on repair and rehabilitation of the concrete. Fire damage assessment is also when the structure has been subjected to fire damage, or fire has been exposure to fire has been then these are the special tests: thermogravimetric analysis, that is TGA, or X-ray diffraction. Here, the changes in the chemical composition of the concrete take place at a temperature above 200 degrees centigrade. And using this thermogravimetric analysis or X-ray diffraction method of analysis, those chemical changes are determined, and the temperature to which extent the concrete had been actually exposed, that is determined. You see, concrete starts getting the strength of the concrete starts getting reduced at a temperature above 200 degrees centigrade. Up to 200 degrees centigrade, if its concrete is exposed, perfectly fine. But above, if using this thermogravimetric analysis, those chemical changes are noted, and through those chemical changes, we arrive at the temperature up to which extent the concrete had been exposed. So using this method, we determine the temperature of the concrete, the deteriorated concrete, or the concrete which was exposed to fire. We determine to what temperature that concrete had been exposed. And based on that temperature, we assess the strength of the concrete, remaining strength of the concrete, using a chart. So using this method, we are determining the temperature, maximum temperature to which the concrete had been exposed. And using that temperature, we arrive at the remaining or balanced strength of the concrete. So this forensic examination is nothing but a highly specialized field, and it is a detailed exercise which requires lot many operations by the team of experts, and finally arrive based on this NDT. Through this table, we arrive at
excellent presentation. Now I request
I
few
seek
questions. Questions hurriedly because
because
we have taken a lot of time.
my presentation is backed by the field experience, and maybe that I might not have been able to cover all the nitty-gritty points in this limited period. So if you have any questions, you feel free to ask me the questions. I will be happy to reply to those questions.
Friends, if you have any questions, Vikas, please, tell,
Yes.
those questions.
Yes,
Please,
there are some questions in the Q&A. The
please,
first
please.
question is, yes, sir, the first question is Mr. Venkat Gavaraju asks, after repair, how to calculate the extended life of the structure?
After repair, if you see, after repair is a big question mark. First of all, repair is a big question mark. If the proper repair is carried out, structural repair is carried out, wherein the concrete in contact with the reinforcement is fully replaced, then the life of the structure will be as good as that of the new structure.
Thank you, sir. The another question is by Mr. Sitaram Agarwal. Is there any code for testing procedures for concrete strength?
Yes, there are codes. This is what I have mentioned about the UPV test and the concrete code test. There are codes available. Smith-Hammer test, all these codes are available. Some Indian standards are available. Wherever Indian standards are not available, there are British standards are available, which I had listed in my presentation slides.
Yes, thank you, sir. Dr. F.P. Anchuri asked, which computer-based analysis tools, AI tools for forensic assessment of reinforced concrete structures are commonly available in India?
As far as artificial intelligence tools are concerned, I am not exposed to those tools, but being a rigorous exercise wherein a lot of data has to be analyzed. So for data analysis, the data which has been generated using the visual examination, the data which has been generated using the NDT exercise carried out in the field, all this data has to be properly, this AI tools can properly assess this data, and based on that they can arrive at the appropriate repair and rehabilitation methodology. So since I am not exposed to AI tools in this particular field, so I will not be able to give the exact reply that what type of recommendation it will give. But AI tools can be appropriately made for analysis of this data collected during the field investigations.
Yes, sir. Thank you, sir. Mr. Venkata Gavaraju asked again, how to do the analysis of the deteriorated structure in the finite element method to plan for strengthening?
You see, if you are strengthening for higher loads, or if you are using if you are using the structural analysis to find out the residual strength. So all these can be, there are structural analysis tools wherein you are applying it, wherein first of all you arrive at the actual structure. You can find out the residual reinforcement in the structure using the reinforcement locator, reinforcement bar diameter you can find out, bar diameter, thickness of the cover concrete, all that you can find out. Also, you can find out the rate of corrosion. If you are able to get the rate of corrosion, you can find out the residual life of the structure also. But this lot of work has been carried out in the last 25 years but residual life of the many research papers are available for assessing the residual life of the structure. So now it is possible, but again, it is a big question mark because structural life is dependent on a large number of factors: exposure conditions, maintenance conditions, and how the structure is exposed during its usage. So all these things do matter. So to assess actual life of the structure at any stage is a big question mark because just because the usage or the exposure conditions in the future are not known. Maintenance conditions in the future are not.
Thank you, sir. There is the last question is, he says, Mr. Jayakumar says, adding additional reinforcement to make up the steel area that is lost is a tough activity, I hope.
It is undoubtedly a tough activity. In case of RCC slabs, it is a very tough activity. In case of RCC slabs, I had been recommending, and it is recommended. It is much more economical to replace the RCC slab if additional reinforcement is required. But in case of beams and columns, it may be economical to put additional steel wherever steel has gone short due to corrosion.
Yes, sir. Thank you, sir. These are the only questions, sir.
Dear Sharma, your representation was really excellent, and more than 100 people who have attended, I'm sure, will get benefit. And the basic things that he told us to do the proper condition survey, visual inspection, planning, conduct non-destructive tests, core tests and destructive tests, then corrosion assessment, and whatever you do, it needs a lot of experience, and only the experience and the specialized work. And I'm sure the people who attended will definitely get benefit of Sharma's lecture. And we are again grateful to Engineer Sharma to spare his valuable time and share his long experience in the field of existing structures. See the planning and design of new structures. These days, your software programs are there. But here in existing structures, you really need experience and specialty for years. It is not a half days training job. It is a continuous process. And Mr. Sharma, he has spent his life, and he's able to write a guideline manual, which is again available in the, straight away, one can, take out, in the website. And once again, we thank on my behalf and behalf of his sector engineers to Engineer Sharma for his valuable lecture. Now the lecture again by the different author, different topic would be on 24th of October. So this will continue, friends. And then anybody who wants to share his experience to lecture, he is welcome to come and give and here dissipate this knowledge. And so thank you once again. And now let us now, I think, conclude this today.
Thank you, Dr. Dhawan. At the same time, my suggestion is those who have any further questions, they may refer to Handbook on Repair and Rehabilitation. They may refer to Handbook on Repair, CPWD Handbook on Repair and Rehabilitation. With this, thank you.
Thank you, sir. Thank you.